Okay, hi there. We're going to have this video, and what I'm going to explain here today is going to be about regarding the two types of errors. And part of remark two under the types of physical hypothesis is that we would need to highlight that there is no such study which is entirely perfect. Okay, so in short, there's no study which is perfect. There will always be a chance of error. And a statistical test uses the data obtained from a sample to make a decision about whether the null hypothesis should be rejected or should it not be rejected. So based on that facet, we enter these two types of errors. So we have type 1 error, which we also call as your alpha, and type 2 error, which is called as your beta. So let me explain a bit. Type 1 error occurs if your null hypothesis is rejected when it is true. Okay, so you can imagine that if a null hypothesis is true, the correct decision would be not rejecting it, right? Because it's true. Okay, I hope you get that. So, um, if a statement is true, you should not reject it because it is true. And type 2 error occurs if the null hypothesis is not rejected when it is false. So, logically speaking, when your null hypothesis or any statement at all is false, you should reject it. But if the statement is false and you did not reject it, that will result to an error. So we have these two types of errors that might happen. Now, in a single take, believe me, I also been through there. It might not be that understandable, but I'm gonna give examples, hopefully to make things simple. Now, to highlight more detailed, type 1 error or your alpha occurs when the null hypothesis is rejected when it is true. So that is the null hypothesis is wrongly rejected. And another term for that. Hopefully that these statements help your understanding with the types of errors. And the type 2 error, or also known as your beta, occurs when your null hypothesis is not rejected when it is indeed false, or in fact false. So that is your null hypothesis is wrongly rejected, or shall we say that not rejecting a false null hypothesis. So we're going to put this in a table form, and we can see that these are the things that will follow. If you have a null hypothesis which is true, the correct outcome would be not rejecting it because it's true, right? So, um, similarly, when your null hypothesis is false, the correct outcome would be not rejecting, or sorry, if it is false, the correct outcome is rejecting it because it is indeed false. But if the null hypothesis is true and you rejected it, that's an error, right? We also call that as your false positive. This false positive probability is equal to your alpha, okay? And also, when your null hypothesis is false and you fail to reject it, even though it's false, it will result in an error. We call that error as a type 2 error, also known as your false negative. And the probability of having this type 2 error is what you call as your beta. Now, to help put things in a simple perspective, let us, this is a popular example, by the way. Your null hypothesis is that you are not pregnant, and the alternative is that you are pregnant. This is an example of a type 1 error, okay? So this is a man, okay? Uh, a male, but the doctor says you're pregnant. That's clearly an error. Why is it a type 1 error? Because your null hypothesis is true. This man is not pregnant. But the doctor rejects this null hypothesis, saying that you are pregnant. Okay, so this is rejecting a true null hypothesis. Conversely, type 2 error is like this, all right? So this girl here, this female, is obviously pregnant, and the doctor is not rejecting it. Okay, so why is this happening? Let me explain. This picture is showing that the alternative is true. So therefore, if the alternative is true, the null hypothesis is false because she is pregnant. So this doctor, though, is not rejecting that statement. So this is not rejecting a false null hypothesis. Okay, hopefully with that example, it's all cleared up. Hopefully a bit that the difference of a null hypothesis and an alternative hypothesis. So recall this is your alpha, and this is similarly, this is an opposite your beta. To give more examples, to see the whole picture, this is what should happen. This is the correct one. The true positive is you're pregnant. This is the correct decision. This is correct reasoning. She's pregnant, so the doctor says she's pregnant. Um, this is a man, so you are not pregnant. The doctor says that you're not pregnant. Now, this is false positive or type 1 error. You're pregnant. And this is false negative. You're not pregnant. But, the picture shows that the girl is pregnant. Okay? So, in a test of hypothesis, what we're particularly interested with is your alpha, right? You can always see this in research papers and articles. You can always say that there is always an alpha there. But why is that? Why is that so? Let me explain it in a bit. But let's put some denotions. Alpha is your also known as your level of significance, or simply as your alpha level, and your one minus beta, or the complement of your type 2 error, is what we call as the power of the test. Now, why are they called like that? Let me explain. The level of significance, or alpha, is the probability of rejecting a null hypothesis while it is true, also known again as your type 1 error. Power of the test is the probability of rejecting the null hypothesis while it is false. So the power of the test is the correct decision. Let me go back to the slide before. So notice here in the first row, rejecting the null hypothesis. When it is true, that's an error, that's your alpha. When it is correct, that's your power of the test. Okay? Now, going back. So level of significance and power goes hand in hand. Level of significance is the probability of type 1 error, whereas the power of the test is the probability of avoiding a type 2 error. If all other things are held constant, the level of significance, as this alpha level increases, the power increases as well. So the more that you increase your alpha, the test becomes more powerful. Um, this is because the larger alpha means larger rejection region, or the critical region will be increased. Thus, the test will have a greater probability of rejecting the null hypothesis, even if it is true or not. But it's increasing the probability that you are to reject the null hypothesis. So it is actually increasing the alpha, the type 1 error, and increasing the power as well. So this translates as a more powerful test. The price of this is that you increase the risk, of course, of having this type 1 error. Okay, so that's your price of increasing your alpha level. It will become more powerful, but the type 1 error would also increase. You can actually uh, find a leeway to decrease this. So you decrease the alpha, only that, again, the power of the test will also decrease. Let's move on to the next slide. An alpha level of 5%, or zero point zero 0.05, is reasonable and widely accepted by all scientists and researchers. The null hypothesis can be rejected if there is less than 0.05 probability of committing a type 1 error. So that's what we are looking for. So if your p-value, that's your probability value, will fall with a less than 0.05%, meaning that's reasonable, that it's okay for you to have an alpha level of 5%. It's acceptable in convention. Okay? So with that, your alpha is 5%, saying that there's 5 chance in 100 that the result term significant could occur by chance. So it's very, very small. Okay, in some aspects it's not that small, but it's acceptable. Take note, the probability of making a type 1 error, alpha, can be decreased by altering the level of significance. So what you need to do is just adjust the alpha level, and you can actually control the probability of type 1 error, though the price for that will be the opposite of what would happen before. It will be more difficult to find a significant result, because resulting in a smaller significant rejection region, or a smaller rejection region rather, um, and of course it will be safer, but it would be difficult to find a significant value for a test. um, Therefore the power of the test will be decreased. If the power of a test will be decreased, remember that the power of a test is the complement of your type 2 error. Remember complements in your probability. If you decrease the power of the test, the type 2 error increases. So, okay, let me get back a moment. 5% is acceptable, but if you think that this is too high, you can decrease the alpha to lessen the risk of type 1 error. This will translate to a less powerful, a lesser a test with the lesser power. But and also, if the test will have a lesser power, the type 2 error will increase, risking the type 2 error on the other hand. Well, the problem on hand is risking the type 2 error. We can adjust the type 2 error risk by increasing the alpha level. So we increase the alpha level. This will increase the power of the test, resulting that the test might, you know, easily find a significant result, but it will increase the chance of type 1 error. Okay, so you might think in this point that you have no choice. You need to choose the type of error that you are willing to risk, because if you adjust one error, the other error will increase. If this error will be decreased, the other error going back will be increased. So in short, we have no escape. We need to find a type of error which we are willing to risk, because the errors are there, and we cannot say that there will be no errors. There will always be errors. So to which error are we willing to risk? So let me give you the scenario to give you a perspective of what error are researchers and scientists willing to risk. Suppose there's a test for a particular disease, and if the disease really exists and is diagnosed early, it can be successfully treated. If it is not diagnosed and not treated, the person will become severely disabled. If a person is erroneously diagnosed having the disease and was treated, there will be no physical damage done. So I think it would be easy. Let us let us suppose that the disease here is COVID-19. I hope everyone would easily understand that in this case. If you have COVID-19 and you're diagnosed early, you will be successfully treated, right? No doubt. If you are not diagnosed and not treated, but you have the disease, you will become severely disabled, shall we say, or even death might happen. But the thing is, because you're not diagnosed and you're not treated. But if you are erroneously diagnosed as having COVID-19, but in fact you don't, you'll be treated. You'll be given medicine or something. No physical damage is done. Now let's put that in perspective and put that on a table. Okay, uh, you have a disease. You have COVID-19. You have no COVID-19. You are positive in COVID. Sorry, you're not positive, not diagnosed, and you're diagnosed. You are, say, positive. This is negative. Shall we say this is positive? Um, of course, if you don't have COVID-19, you will become negative in the test. That's the correct thing to do, or the correct decision, or the correct thing to happen. If you have the disease, if you have COVID-19 and it became positive, well, yeah, that's right as well. Okay? Notice that if you don't have the disease, if you don't have COVID-19, and you are diagnosed to have COVID-19, we call it type 1 error, that is also known as false positive, because you don't have the disease, but you were diagnosed to be positive. So that's false positive. You will be treated, but no harm will happen to your body by the treatment. Alpha. What about the other type of error? Here, you are diagnosed to have the disease. You have COVID-19, but the results turns out to be negative. That's a false negative. That's an example of a false negative, because um, you do have COVID, but the test turns out to be negative. What happens here is that irreparable damage would be done, because you do have the disease, but the test turns out to be negative. Therefore, you're not treated, and it may lead to severe disablement, or severe sickness, or even death. So hopefully you got that. Okay, if there's something, parts of the video which is quite difficult to understand, kindly repeat it. But let's end with this part. Our decision would be always to avoid type 1 or sorry, type 2 error. To avoid type 2 error and have a higher type 1 error or a level of significance because we are willing to risk the type 1 error. That is also the reason why we always see the alpha level or the level of significance in research papers, but never the beta, or very seldom the beta. But and alpha is always there because we're willing to risk the alpha level. Okay, so hopefully you understand that video. This is a very detailed explanation of the two types of errors, type 1 and type 2 error, and lots of examples are given. Hopefully you understand that. And I'll end in this part. Thank you very much. And I'll be seeing you in the next video. See you.